Okay, so in this description of a new medicine, it mentions that this is an experiment. So if it's truly an experiment, then it needs to be random. Then it should be random, and there should be it should be random, and it should be that each subject should have no effect on the results of another subject. That is a reasonable expectation. Okay, that's a reasonable expectation. So we've already knocked off two of the conditions. We've talked up the randomization condition, and we've talked up the plausible independence condition. The only thing we need to check is we need to do the success failure. Okay, so let's check on it. If you have 53 subjects times 0.27, oh, we should write that down. The sample solution proportion of successes is 0.27, so Q equals 1 minus 0.27, so that would be 0.73. You can't read that. 0.73. Okay, so that's what we're looking at right now. So I'm going to do that, and is that greater than or equal to 10? The other one to check is 53 times 0.73 greater than or equal to 10. And really, you only have to check the first one because it will if it works here, we're going to check that one there. So when I do that on the calculator, so when I did that one here, whoops, on the calculator, and I put it over here, it turns out I get 14.3. So 14.3 is greater than or equal to 10. So that works. That's going to work as well. So we know that we have a big enough sample. So the sample is big enough. Okay. The only other thing we have to do is the 10% condition. Okay, and so 10% condition. Well, we had 53 subjects in our sample, and n equals 53. Okay, and so we just have to check. Well, it seems reasonable. So this is our 10% condition in red, that more than 530 people have the condition in the population. Have the condition in the population. So I've met all the conditions. So now I can go and do a 95% confidence interval for the actual cure rate. Okay, so I'm going to switch to the next screen. I'm going to rewrite some of the stuff up here. So we said P hat is 0.27, Q hat is 0.73, N equals 53. And we want to make a 95% confidence interval. Okay, and now remember we did it in the first example. The Z critical value is plus or minus 1.96 for 95% confidence interval. Earlier, so that's a 95% confidence interval. The Z star, because the next question is what about a 90% confidence interval? That was plus or minus 1.645 for a 90% confidence interval. So this is 95, and this one is 90% confidence interval. Okay, so I'm going to do both of these. So I'll do the 95% confidence interval right here. So I'm going to get 0.27, so plus or minus the margin of error. Now the margin of error is z star, which is 1.96, so that's z star, times the standard error. So remember, the standard error is the sample success, the sample failure divided by n, which is 0.27 times 0.73 divided by 53. And we're going to take the square root, and when we get that, our standard error for that is it's 0.061. So about 6%, plus or minus 6%. So plus or minus 0.061. Okay, so now I'm going to put that in here. The standard error is 0.061. Okay, when I do that, I'm going to get 0.27 plus or minus 0.12 is basically what it is. So my confidence interval 95% is 0.15 and 0.39. I'll interpret this later. That's the 95%, so let me put that in a box. Okay, that's the 95% one. Now I'm going to do in blue, or in green, excuse me. The 90% confidence interval, will be really fast, is 0.27 plus or minus 1.645 times 0.061. So we get 0.27 plus or minus 10%. So this one, the confidence interval, is 0.17 and 0.37. Okay, so I'm going to talk about what those mean here in a second. Okay, so what this says is, so I'm going to do it I'll do it in green. I'm going to say whoops, I got the wrong thing there. I am 90% confident the true cure rate for the medicine is between 17% and 30%. Sorry, I just totally wrote the wrong number down there. 37% of patients. Okay? If I wanted to do it for a 95% confidence interval, then I just change this to 95%, and I change this to 15%, and this to 39%. And that would be the 95% confidence interval. Well, I just wanted to make sure we did everything, and it looks like we did, except for one thing. But I want to go back here. We did this. We created 95. We made it 90. That doesn't make it wider. That makes it narrower. Okay? Made it narrower. And the advantages are of the 90% confidence interval. The advantage is that it's more precise because we know it's between 17% and 37%. But the disadvantage, so that's a plus, the minus is that we're not as confident in getting the true proportion. Well, you can't see that. The true the true proportion of the true cure rate. So so that would be why the 90% confident, it's narrower, so we're a little bit more precise, but we're not as the downside is we're not as confident that we got the real one. Where the 95% confidence interval, if I can do that one here, the negative is that it's wider, and so it's less precise because it's between 15 and 39, but we're more confident that we have the true cure rate. So so that's a plus. That's a plus for that, and a minus for that. So there we go. That's the kind of discussion you need to have.